Hi guys, we have a little bit of a tough lesson to do over just video. It would be best if I could see your faces and we could talk through your questions as we go, but I want you to just bear with it and then we can talk during the chat and see if we can straighten anything out, okay? See if I can just explain it, break it down a little bit for you. So we've been doing two different kinds of distributions. We did binomial distribution first, and we had this fancy formula that we did. Binomial was when you had successes and failures, like tossing a coin or tossing dice, picking cards, things like that. Normal distribution meant that it had a continuous distribution, and so you could have all those little in-betweens, and so we had to use our tables that were on our pink sheets, our salmon sheets, okay? So what we're going to do today is use the normal distribution, the tables, and approximate a binomial distribution, which is where we had to create the probability of each and every one of those, and we made a big table out of it, or we put them in our calculator, okay? So we're using normal to approximate binomial. It's going to say in the problem, approximate the binomial distribution. Okay, so trying not to make it tricky when they want you to use it, but you're going to have to watch your wordings very, very carefully on problems when they start mixing them up, okay? All right, let's get to it. So I want to compare and contrast the two. Like I said, in a binomial, the data is discrete. We had successes and failures, and we used that formula, the n choose x, p to the x, q to the n minus x. And the graph was usually skewed. Now we did graph one of them in class, and we noticed that it was way skewed. It's not always, though. Sometimes it is more like a normal distribution, and that happens when this happens. N times p and n times q, both of them have to be greater than or equal to 5. Why is 5 such a magic number? Well, so here's the thing. If you have a sample of at least 30, the sample is better, okay? And that's why when we did our project, I told you to get at least 30 pieces of data, okay? When you have at least 30 pieces of data, then it's a better group of data that will approximate the population a lot better. N is the sample size. Sample size, there we go. And P, remember, was the probability of success. So if I have at least 30 in my sample size, and I take it times the probability of success, if that number is greater than or equal to 5, we're in good shape. But also has to have the sample size times the probability of failure. Remember, Q was failure. Probability of failure. That also has to be greater than or equal to 5. Okay, so both of those have to happen, and you've got some homework problems that'll ask you, is this okay to use a normal distribution for? And the way that you know is if NP and NQ are both greater than or equal to 5. Okay? On a normal distribution, it was continuous data. We used our z-scores, z equals x minus mu over sigma. We found the area under the curve on our tables, and the graph was very symmetric. It was very nice. But binomial can be kind of nice too, and some kind of symmetric, and that's why we're going to be able to do this approximation. All right, so let's get to it. there's a funny thing going to happen, and we call it the continuity correction. What it means is our distribution is binomial, but it kind of looks normalish. Okay, it's going to be fairly normal. Here is the x value that I'm wanting to find the probability for. Whether I want the probability to be less than x or greater than x or equal to x, this continuity correction is going to take a little past x. So it's going to round it down by 0.5, or it's going to round it up by 0.5. Okay? The continuity correction is always 0.5. And what that's doing is it's converting a discrete variable to a continuous variable. And that's what's happening. And we always move it 0.5. Okay? Always move 0.5. All right, 0.5. So, what happens is, if I want to include the x, and I want to say everything greater, at least x, greater than x, then what I'm going to do is shift over by 0.5 and just use all of this up here. Because if I want everything, the probability that it's greater than x, then I want to not include the x. If I said at least x, then it would shift down and include all of this. And that way I'm including the x. Now we're going to go into more detail with that here in just a second. But the continuity correction means I need to shift one way or the other, to the left or to the right of it, by 0.5 always. And we're going to write that on our formula sheet here in just a bit too. Alright, so here's the process. You might want to hit pause so that you can write some things down, okay? First, you're going to check and make sure NP and NQ are both greater than or equal to 5. Okay, both of those have to happen. Now, we need a mu and a sigma. In order to use normal distribution, you have to have x minus mu over sigma. So mu is going to be the NP that you found, and sigma is the square root of NPQ. This is on your formula sheet. Here, down here for chapter 6, there it is. I also want you to put in here continuity correction of 0.5. I put plus or minus 0.5 because we're either going to add 0.5 or subtract it. Okay, so when we do this normal distribution approximation of a binomial, we have to go find our mu and sigma, and I like to call this guy Q, NPQ, and we're going to have to switch our x to be 0.5 above or below. You want to put an x in there? Will that maybe make it better, because I'm not going to be there to remind you. Okay, but we're still going to use this z to go find a z-score, and we're still going to look it up on the table. But you just got a little bit of work to do first. You got to go find your mu and your sigma. Alright, so we make our continuity correction and change our x, and then finally we go and find the probability just like our normal. Okay, so these are our steps that we're going to follow. You should make sure that you have them written down before you go on. Alright, I did want to show you this just so that we can, here, I'd like to focus on one at a time here. I want to show you how this works, okay? I know this is a very strange thing for me to be saying. Let's say that I wanted to find the probability that x is at least 8. If the probability is at least 8, that means I want to include the 8. Since I want to include the 8, and 8 is here, I want to shift down to 7.5 and do x is greater than 7.5. Okay? Because I want to include the 8. If I wanted more than 8, if I want to find the probability more than 8, that means I don't want to include 8, and so I'm shifting up. Here's 8. I'm shifting up to 8.5. So I'm finding the probability that x is greater than 8.5. This is the continuity correction. Now let me show you something here. Oh, not yet. Okay, so this one is at most 8. So do we include 8 when I say at most 8? Yeah, 8's included in there. And so I'm going to shift it up to 8.5 so I can include the 8. So I want it less than 8.5. At most 8 includes the 8. Okay. If I said x is fewer than 8, fewer than 8 does not include the 8. So I'm going to shift down to 7.5. Less than 7.5. Okay. Now here's the tricky one. You ready? Exactly 8. Normal distribution is about area. So I can't find the area of one line. I have to find the area around the 8. So what we're going to do is find between 7.5 and 8.5. Okay, exactly 8. All right, I need you to make sure that before you move on, you understand what just happened here. This is the continuity correction part of it. We're going to shift either up or down by 0.5, and you have to make a decision on each problem. Am I going to shift up or down? Or both, right? Okay, so hit pause and study that and make sure you understand what just happened, or hit rewind and listen to it one more time, okay? All right, when you're feeling good, we are going to describe the region. So, we want the probability that more than 12 senators are women. Excuse me. Probability that more than 12 senators are women. Do we want to include the 12 senators? No. So, more than 12, excuse me, means I don't want to include the 12. I want to go higher. So my continuity correction goes to 12.5. So it is going to be, and you're going to describe this as right or left. So we're going to go to the right of 12.5. Or 12.5 and everything to the right. I don't know how it says it exactly on the program, but that's what it means, okay? I'm going to show it to you all 3 ways so that you know what's going on when you get there. Probability that fewer than 5 passengers do not show up for a flight. Fewer than 5. Here's 5. Do I want to include the 5? No. Fewer. So I'm going to go down, and I'm going to the left. So I go to 4.5. So everything to the left of 4.5. Neato? Okay. I want you to, oh, not that one. I want you to try this out, hit pause, and describe the region. All right, so inclusive means, here's 12, here's 16. I include the endpoints. So everything between and include the endpoints. So I need to go out farther. So I'm going to go everything from 11.5 to 16.5. Or I could say between 11.5 and 16.5. So there you have it, all 3 ways. Okay. Probability the number of students is exactly 4. Here's 4. I need a window around the 4, so I build my window and everything in between. Well, what's my window go between? It goes from 3.5 to 4.5. Or I could say it in words, between 3.5 and 4.5. Okay? Normally we wouldn't talk about 3.5 students and 4.5 students, right? Or 11.5 computer power supplies. No, it doesn't make sense, right? But we're taking this binomial and turning it into normal. So we are making a window and an area for us to look up. All right. I'm going to stop there and put the examples on a second video. Make sure that you understand where this is coming from before you go and look at that, okay? All right, see you in the next one.